Okay, let's take a look at how to multiply polynomials. First, we start with a monomial. So you take one monomial, which means just one term. You can take apart the terms and you can group the coefficients and the variables. Remember, the commutative property allows you to take apart multiplication. Order doesn't matter. 2 times 3 is the same as 3 times 2. So when I look at 5x squared, I can take it apart. 5 times x squared times 4 times x cubed. I now have 4 separate entities. I can multiply the 5 times 4, which is 20. X squared times x to the cubed is x to the 5th. Now that's assuming everybody has remembered how to do multiplication with exponents. If you have the same base, you can add the exponents. So I now have 20x to the 5th. Next example, 2r squared t, 5t cubed. You can see it's a lot of work to pull it all apart, but I just want to make sure that you see the base the long way so that whenever you don't remember the shortcuts, everybody can go back and just do it the long way. 2 times 5 times r squared times t cubed. You see I've already grouped them now, and I've put my coefficients together and my variables together with my exponents. There's only one r, so it's 10r squared t times t to the 3rd power. Remember, there is a invisible 1 here. There's an invisible 1 exponent with this t, so it's a 1 plus 3. That's how I get t to the 4th power. Let's take a look at another example. It looks very complicated, but it doesn't have to be. I took every piece apart, but I pulled out my coefficients, then I pulled out all my x's, I pulled out my y's, I pulled out my z's, and now I started to combine them. So I have my 1/3 times 12, which is 4. X squared, x third, 2 plus 3 is 5, so x to the 5th. Y to the invisible 1 times y to the 4th is y to the 5th. Z squared and z to the 5th, 2 plus 5 is 7. Hopefully it seems a little easier now. What if I have to multiply a monomial times a polynomial? Well, this is simple. We've been doing the distributive property for years. All I'm going to do is take my outside value, my monomial, times each term inside my polynomial. 5 times 2x squared is 10x squared. 5 times a positive 1x, positive 5x. 5 times a positive 4, positive 20. I have no like terms here, so I don't have to combine anything. I'm done. But what happens if I am a little more complicated? 3ab instead of just 3. It's okay. I'm going to take 3ab times 5a squared. Look at, there it is. I could take every piece apart the way I was doing in the previous slides and do 3 times 5 times a squared times b. Or I can start to look at it and I can envision 3 times 5 is 15. A times a squared, a to the 3rd. B, no more b's, just b. Next term, 3, there's only one coefficient, bring it down. A, there's only one a. B times b is b squared. Like terms have the same variable and the same exponent. Only if you have like terms can you combine the coefficients. Otherwise, you are done. So if you thought for a moment that these were like terms because they both had an a and a b, they are not. They do not have the same exponents, so you cannot combine these together. Here we go. I have a nice distributive property for you. I show it to you both ways. You can do it easy. 5 times 2 is 10. S squared times s to the 1 is s to the third. T to the third, there is no t here, so just bring it down. 5 times negative 3, remember the sign goes with the term, negative 15. S squared, there's no more s's, bring it down. T to the third times t to the second, t to the fifth. If you would rather, go ahead and spread it out. 5 s squared, t to the third, 2 times s. Now start rearranging and combining. You're going to get the same answer. So if you don't see it in your head that you can just use distributive property, then list every part separately. So depending on what grade level you're in, this in the blue might be easier for you. We're at the 8th grade level, and actually this is an algebra lesson. So this is my algebra students that are doing this, Algebra 1, same that you would have as a freshman in high school. You should be able to see this, and you should be able to understand the top purple section. What if I have a binomial times a binomial? Well, you remember that there's something called FOIL, and that's going to be coming right about now. I can do what I like to call double distributive property. I take my first term times everything in the second polynomial. Then I take my second term and I do it again. So x times x is x squared, x times 2. Now I do the second, the double. 3 times x, 3 times 2. Combine like terms, and I'm done. This is called FOIL. The problem, not that it's a problem with FOIL, but you have to remember what FOIL is, what it means, which hopefully, here we go. Look, I'm showing you. FOIL, first, outside, inside, last. It's exactly what I just did. First, 3 times a. Outside, the 3a, or outside is a times 4, negative 4. So I'm doing my first set of distributive properties. The I and the L are my second set. You're going to get the exact same answers. A times a times negative 4. 3 times a, 3 times negative 4. Whether you call it FOIL, which you're going to see on every standardized test. I don't think you're going to see a double distributive property. That's just what I like to call it. It just makes more sense to me. So here we are. We have practice. 2a times a, 2a squared. 2a times 4b squared. 2 times 4 is 8, ab squared. Negative 1b. Remember that you can put that invisible 1 in front of your variables. I can have negative 1b squared times a, which is giving me this. Negative 1b squared times 4b squared made that a negative 4. B squared and b squared, b to the 4th. Now I need to combine like terms. Look, they're not written in the same order, but they are an a and an a b squared and a b squared. These are like terms. You can rewrite them, remember, using the commutative property, and you can rewrite them and put the a first if it makes you more comfortable. And now you can combine them. I actually have a 7ab squared. Remember, these are like pieces of a puzzle. As long as you keep the sign with your term, you can grab that piece of the puzzle and move it anywhere you want. I'm going to go by order of degrees. So I'm going to take this b to the 4th power, because my degree is 4. I'm going to make it go first. Degree of 3, degree of 2. You need to work slowly and carefully. I might be speaking too fast, but I expect you to go back and watch this over again. And I'm trying not to make my video 45 minutes because I'm afraid you won't watch it. I just want you to see multiplication of polynomials. I'm going to stop here and start a new video.